Okay, good morning. And What I would like to do is talk today about what we do in Nace, as we now refer to it as AMP. Um, in this effort, Nace has got a very large commitment in terms of development of standards. And as we'll talk about, there are various groups, a multitude of groups that address different types of standards, both including materials, equipment, processes, and both onshore and offshore, mainly for oil and gas, but Nace has started to venture into the water industry as well. So with that, I'd like to show the next slide, which is what we're really going to cover today. I will talk about the introduction of Nace and how Nace evolved over the years, but particularly most recently as an organization. We'll talk about standards. That's really the emphasis of this discussion today is what are standards, why do we have them, how do we use them? We'll talk about the development of both new standards and revised standards. I'm going to show you an example of a revision of what the elements of a coding standard consist of. I will speak from a coding standards perspective because that's been my involvement in Nace and in the corrosion industry. We'll talk about as you go through the process of developing a new standard or a revision of a standard, what happens within Nace relative to balloting and what you have to do to address the comments and revise those comments and resolve them as you're developing the standard. I will walk you through the standard groups within Nace today. There are 23 different standard groups, and within each group you will have committees. The various standards. I chair the SC03 standard, which has 24 different committees that address different elements of corrosion coatings, as well as test methods. And then I have some summaries, and I have my own takeaway at the end for the group that I'm talking about today. So to start with, what does Nace offer to the corrosion industry? Essentially, Nace does a multitude of things. They offer technical papers. They offer symposiums and forums at both their global, worldwide meeting once a year. They have what we call Corrosion Technical Week, CTW. That's generally in September, and that's where all the various committees and standards and groups come together and work individually to develop their standards or make revisions to the standards. So that's what really does Nace offers. They also offer technical papers, and both technical papers and white papers, and we have technical exchanges. So Nace is a very complex organization with a multitude of opportunities and what they present to the industry, but all from a corrosion standpoint. I particularly work on what we call developing of new standards for both equipment, materials, and processes. We do work on both new standards, as I said, as well as revised standards. Within Nace, the policy is that a standard is valid for 5 years. At the 5th year, you need to start working on a revision or what we call a reaffirmation. After it's been read and reviewed, if there's no changes, then you can go out for a ballot and have it as a reaffirmation with no changes. If there are technical changes to the standard as part of that process, then you go through a revision and balloting and then ultimately a publication. Up until 2020, Nace had what we call the STG format, and that was Standard Technical Group. And within that group would be focused on coding standards. They would be writing white papers, technical forums, technical exchanges, and essentially an interaction of the corrosion industry. And it was very complex. You had chairs that were running the various STG groups, and you had a multitude of activities going on. And that is essentially what STG was all about. In 2021, Nace decided that we really needed to focus on getting standards published faster, because generally under STG, it could take 3 to 4 years from the time you started working on a standard to the time it was completed and published. And Nace said, when we look at what at the time what SPC was doing and what Ian and other groups were doing, American Waterworks Association, which I would refer to as AWWA, these organizations were moving standards along, at least from a perception standpoint, much faster than Nace. And they said, we really need a focus on standards and separate that out from the technical forums and technical exchanges and symposiums. So they formed in 2021, actually at the end of 2020 and beginning of 2021, what we called the Standards Board. And that was, the whole focus would be on standards. And under this, the expectation was that we'd be able to turn around a standard in 12 to 18 months. Now remember, all of us within Nace and AMP are volunteers, except for the staff that works for Nace. But as the members of Nace, we're the ones that really drive the standard, drive the revisions. So their intent was, let's have a focus only on standards and form what they call the Standards Board. And then from that, they form what we call the standards groups. And today there's 23 different standards groups, and each one has a chair. As I said, I'm chair of SC03, which for coatings for immersed and buried pipelines or structures, but mainly pipelines. And in that, it's both coating standards as well as test methods. That's what's contained within SC03, and we'll just delve into that a little bit later. So essentially, in 2021, we then had ourselves organized to be able to say, we have 23 different groups. Each group has a chair, and within each group, there is a multitude of standards. I know in SC03 as an example, I have 24 committees and standards that we work as a group. And there's other groups that have smaller committees. I know like in electrical and transmission, nuclear power, things like that, they may only have 5 or 6. So that really gives you sort of a background of what, Nace and an organization as it is today. And as I said, we're all volunteers, and our focus is being able to write standards as it pertains to materials, equipment, or processes. So why do we have a standard? Standard is really, first of all, it's a guideline for the corrosion industry. Whether you're building a pipeline, you're building a refinery, you're building a bridge, essentially it becomes a guideline for how you're going to do that. In the case of coatings, we're dealing with coatings like heat shrink sleeves, liquid epoxies, liquid urethanes, tapes, 2-layer and 3-layer extrusion systems. These become the guidelines. As I said, they are a minimum standard. It's not a specification. We separate a standard from a specification. A standard is written by the industry. Generally, a specification is written by a project engineer or an end user for a particular project or day-to-day pipeline construction business that an end user would be using. All of these standards relate to applications of the coatings materials itself. So in a standard, as you will see later on, I have a slide on what consists of a standard. You're addressing, not only the materials, but also its application, surface preparation, how you apply it, and how you test it, both in a laboratory as well as in the plant or in the field, depending on where you're applying it. These guidelines are used principally by the end users, by contractors, consultants, corrosion engineers, those that are writing specifications, project specifications, or as you go into a project specification, you would have a coating specification and a pipeline specification. Excuse me. As I said, they're used by end users, engineering companies, consultants, engineering managers, and used by the manufacturers themselves. If you're a coating manufacturer, one will be participate in writing that standard, and then you will follow that as you participate in pipeline or projects that you're involved with. And as I said, the standard is a minimum standard. It generally meets the requirements of all the manufacturers that are participating. So if you're writing a standard on liquid epoxy, it typically would consist of the manufacturers themselves, and they will be writing the standard that generally most manufacturers would be able to meet that standard. So it becomes a minimum standard. And that standard then is used by engineers, end users, to then write their project specifications, which then raises the bar relative to the properties of the coating, the application, and the testing and utilization of that standard. By the way, if there's questions that you want to ask while I'm going through each slide, please feel free to ask Amajit, and I will try to answer the question at that time. Otherwise, we can do it at the end. The next slide really talks about what are the NACE standards. As I said, there are standards. It's a document that is used in the corrosion industry, a minimum requirement. It really addresses, in the case of materials, as an example, it will give you the type of materials in generic terms. It will talk about the test methods and the values of those test methods. You will generally have tables that will have the properties, both in terms of qualification of a material, and then as you're using the material, it would be a quality control test values and test properties that you would use to test the proper application of that material in the case of coating materials. NACE standards, I say, parallel some of the standards like the American Water Works, AWWA. EN and ISO are much more detailed, but generally they have the same concept in terms of the outline and guidelines of what a standard would consist of. And there's other, obviously, standards, Australia, Korea, India, where these standards are used. I know in India, because I spent a fair amount of my time working in India with the company that I was working for before. And, we worked with the engineers on their specifications and then obviously meeting their specifications. The standards are also used to meet government regulations, whether it's government or state regulations. And as I said, these standards are generally developed by one, if it's a coating material, and manufacturers. You will also have engineers involved with it. You'll have end users. So it becomes, in the way the standards board is now set up, that when a group is formed and a committee is formed, you want to really have three elements. You want to have a manufacturer represented on the committee, and within the group, like the SC03 group, you want to have, besides the end user, you want to have a manufacturer, and then you generally have what we call a general case. You're basically, if you were an applicator or you were a consultant, your general interest group. So those are the three that they try to bring together today under the SC concept. In STG, that was not a requirement. So what they try to do is give a balance, because then it becomes a much better standard in terms of what it offers to the industry by having a manufacturer on it, have a end user on it, and then have a general interest group. And the general interest group is, as I said, is very broad. The next slide talks about how are standards used. They're, as a standard, they're used on projects. If you're developing a particular project, you would use this standard as the basis of writing a coating specification. It's also used many times by a day-to-day project activities that you wouldn't necessarily go out for a request for quote, where you have the materials are approved against the specification that has been written generally by the end user. Engineering companies use these standards to write their project specifications. Likewise, consultants do the same. They use these standards as a minimum standard to then write their specifications. The manufacturers, they use the standard for material qualification. If you're trying to approve a particular coating material, you would generally look at the specifications of the end user and say, do you meet it? So it becomes a dual-edged sword. The manufacturer is developing the standard, but he also has to be on the other side of saying, does my material meet the project specifications or the end user specifications? So they're heavily using this standard to ensure that their material will comply with the project specifications. The contractors use them to ensure that they're properly applying the material, or they're using the right equipment, or they're doing the right process. As an example, in horizontal directional drilling, are they using the right procedures that are written in the HDD standard relative to installing a pipeline under horizontal directional drilling? And then inspectors use the standard to ensure that, again, if it was a coating material, is the material being applied properly? Are the properties of the coating as tested from a quality standpoint meeting what is stated in the standard or in the specification? So it becomes a very valuable document, and it becomes a very important process to ensure that these standards, and I can again talk from a coating standpoint, it's very important to make sure that the coating standard itself is readable, it's understandable, and it can be executed in the proper way as written. And there's a lot of time spent on writing these standards and updating these standards, as we've mentioned earlier. Next slide is just some comments that I'd like to talk about. I'd like to read from the Pipeline and Gas Journal of October of 2021. There was an article written by Jennifer Hifsey, and she's with the International Society of Automation, and she talks about standards. I'd like to read what was in this article, and it says a standard is to provide people and organizations with common technical language, details, and procedures so that they can be used for complex processes, mutually understandable and optimized. And that is really, I think, a very clear, good definition of what standards are all about. And I referred to her in this article. It was Pipeline and Gas Journal, October of 2021. As I said, AMP has 23 different coding groups, or standards groups, I should say, standards groups. And I'm not going to detail all of them. I do have a slide that will outline what I consider sort of major ones that impact at least on SC03. In SC03, we have 240 members. That is what we call our community. Within that, we have 24 standards. These standards are both coding standards as well as test methods. We're involved in writing standards for things like liquid epoxies, urethanes, heat shrink sleeves, horizontal directional drilling. We actually did a white paper on cathodic shielding. That white paper has been published. We were involved. This particular standard is on hold right now, but we were trying to interface Nace with ISO, being able to say that we would take the ISO document and how would we modify it such that it would become a Nace or AMP standard. And that is on hold at this point, mainly because ISO is getting ready to go. It's in the process of revising their standard. So many of us that are in Nace were also involved in ISO. We decided to hold our efforts on that until the new ISO standards are published, which will probably be 2 to 3 years from now. But in the meantime, we're holding it. And the intent was take the ISO standard. How can we make changes that would adapt it more to Nace so that it would be not necessarily parallel, but it would be complementary to the ISO standard. We also have standards related to new test methods. An example, we're working on some new test methods for offshore applications, cathodic despondent test, bendability test, gouge test. These are tests that are written by, again, a committee that the intent is to write a particular standard on how to do a particular test. We also, we have within SC03, we generally have quarterly meetings. That is the general 240 people come together on a Zoom call. And myself and the vice chair, Dan Libby with Chase Corporation. And we have Carlos Fernandez Lopez. He's the secretary from ExxonMobil. We bring the full group together under the Zoom call. And we review various things. We review how are all of our standards progressing in terms of meeting their publication dates, what needs to be done to help these standards groups ensure that they're getting the right traction. We also review what are the needs of that particular standard. Is there things that they need that we can help facilitate that? The Nace staff is obviously pushing hard to be able to ensure that we make these standards within 12 to 18 months, a revision or a new publication. It's hard to get a publication, a new standard written in 18 months. The reality is that takes 2 to 3 years, but a revision, we're hoping to be able to do it in 12 to 18 months. We just had 2 or 3 since SC03 was, or since the standards boards was started. In SC03, we've had 3 standards published this year, late this year, well within our 12 to 18 months. So we see that there's a focus to that. Besides, and what we do in these quarterly meetings, we also ask the industry of these 240, which is our population within SC03, what are the new practices out there that maybe require a new standard? What is the new technology? And that becomes a theme in every one of our quarterly meetings. We also have meetings during the annual, what we used to call corrosion 2021 is an example. They now call it the AMP annual conference, but we come together during that conference and we will have one day dedicated. This 2022, we will have one day dedicated to each of the coatings, each of the SC groups. So in SC03, we will have one day, and in that day, we'll have a general meeting for 1 hour, and then those committees that feel they would like to bring their committee together real time, whether it's virtual or actual, and work on their standard, then we do that. And then we also, during Corrosion Tech Week, we bring these committees together and they work. In the meantime, in those 12 months going on, besides these general meetings, the committees meet individually. NACE sponsors conference calls where they will set up the conference call, and generally the committees meet, I want to say ideally at least quarterly. Many of the groups are meeting every other month, and as a committee they're working to make their revisions, debate, bring in the new ideas, and then go out for balloting. And then the balloting process, as we'll talk about later, becomes a reiteration where, you know, you have comments, you send out a ballot, you get the comments, negative or positives. Those then have to be addressed and resolved by the committee. And you keep going through this process until you've resolved all of them. And then once all of the negatives and positive comments have been addressed, then it goes to NACE for editing and publication. And then you're through your 5 years, and then you start working on it. And several of the standards, even after they've been published, and I can give you a perfectly good example, the SP0394, which is for fusion bonded epoxy, plant applied. The push was because the standard was so outdated, we pushed to be able to get some revisions made within, and it's now out for voting right now and balloting. Our expectation is to be able to have that standard revised in the published in the January to March timeframe of next year. But that committee will continue because they feel that there's other things that they want to add to the standard that didn't allow them enough time to be able to get that standard published within the time frame that we had asked them to do, because this was a standard that was like 7 or 8 years overdue. And the industry was calling, the end users were saying, we do not have a standard that is active today, and we need it updated. So we as an organization said, we'll focus on this particular standard. Let's get the committee working on minimum revisions to bring it up to some state of the art. And then we'll work on the major revisions, which may now take another 12 to 18 months to be able to do. So that's a good example of what happens in SC03 relative to coding standards. As I said, the members of the group, like SC03 group, they're manufacturers, they're end users, and there's the general interest group. And then as you join a committee, you join a group, you would join like SC03, and then you would select on our website, or on the website, there is the various committees under SC03, and you would select to join. You would request membership in a particular committee. And then when you join, you're asked, do you want to be an observer or do you want to be a voter? Not all people want to be a voter. If you are a voter, it is required that every standard that comes out within SC03, you then have to vote on. As an observer, you get to do everything that a voter does except vote. You can put your comments in when you do a balloting process. So if you said, I disagree with this, or I would like you to think about this particular aspect of the standard, that becomes a comment that has to then be addressed. So an observer can give the comments, he just does not, they just do not vote. Whereas a voter does all of that plus voting, but they have the responsibility to vote. And it's a real issue today. Right now, we have 240 members in the SC03 group, but we have 66 voters. So we have a large population, but we have a few that are the actual voters, but those others that are outside of the 60, when these standards come through for voting and balloting, they can make their comments. One other comment is, as joining a committee, you do not necessarily have to be a member of NACE or AMP. They've changed the rules now where you can become, as a non-member, you can still join a particular committee. You're in the industry, you haven't necessarily joined NACE for whatever reason, you can still participate in these standards as obviously as an observer. And the observer gives you all of the benefits of a voter. You participate in the committee members, your voice is listened to, you make your comments. So you have that flexibility now that you don't necessarily have to be a NACE member to be a member of a committee and obviously of a group. And as I said earlier, all of the standards have a 5-year, I don't want to say life expectancy, it's 5 years validity. At the 5th year, you need to start working on a revision. And the expectation today is that we can turn these revised standards around in 12 to 18 months, because obviously NACE wants to be able to have up-to-date publications that reflect what is used in the industry as a practice and as a technology. There's also, as I pointed out here, there is a reaffirmation, and I'll give you the example of one that we're working on right now. I think it's, well, I don't know the SP number off the top of my head, but it's coal tar enamel. Coal tar enamel is an old but proven technology, but it's not really being practiced in the United States. But NACE decided that we do not want to drop this standard. We want to keep it active. So we formed a committee, and that committee will review the standard. And if they feel that there's no major modifications to that particular standard, then it would go back to NACE, it would go out for a ballot, and if there were no comments from the reader poll that was reviewing the standard, then it would be approved and would be published. If there were changes that voters felt needed to be changed, then it would change from a reaffirmation to a revision standard. But a reaffirmation is basically taking generally old standards, many not necessarily being used today, and they will review it, and with no changes, it would go through the balloting process and then be published. So we have that going on as well, particularly with the coal tar, the example that I gave you there. And as I said, having the voter status or the observer status in these standards is important, because even if you are an observer, your voice is still heard in the standard by the committee chair. And each of the committees, generally they consist of about 10 to 12 people. And generally you have 4 to 5 that are the real core group. I know when I was a chair of some of the committees of the standards, we would find that there's 4 or 5 that were generally the ones that would really focus on getting the standard written. And then we would go out and the rest of the group would be more like a peer review. So once the standard had been changed, we would send it to our internal peer group. They would review it. Actually, there's been a couple of examples where we've written a standard. We've made the revisions. We had our internal peer review, and we actually selected a group of persons outside of our committee, sometimes even outside of our group, to do a peer review. We did that recently in one of the standards where we were writing a standard that related to both coatings and cathodic protection. And we said for the coating section, let's go and tap into this group of people that are outside of working on the committee to give us our review. So it was a way of knowing what were the anticipated questions and comments that we might face once the standard goes out for balloting. It's a very good process. And I've been trying to encourage the committee chairs to be able to utilize that process, because it really helps you in terms of ironing out and identifying, problem areas or concerns that you could possibly address before you get to the actual balloting process. The next slide is really the development of a new standard. This doesn't normally happen too often. In SC03, I've been trying to push our delegation of the membership in SC03 to be able to say, what are new practices or new technologies that are out there that are not covered in a standard? But assuming that you've got some new technology or new practices out there, then how do you go about writing a new standard? Well, first of all, you have to identify that you have a new opportunity. And I'll give you the polyurethanes because polyurethanes was one 2 years ago. We identified that in AWWA, the American Waterworks Association, they have a standard on polyurethane, both for mainline coating and for field joint coatings. But that was for the water industry. But in the gas industry, polyurethanes weren't really being used. But we identified that we felt that there was a need. There was some end users that said, yes, we are using polyurethanes in certain applications. So we wrote up a justification, which is the next item you'd have to do. You write up a justification that goes into both the SC chair. It goes up the ladder to the higher ups within NACE and AMP. And the justification is written. There's an approval to do that. Now, actually, I'll give you the example in the polyurethane. In the polyurethane standard, we wrote the justification, and all of a sudden we realized that there is an ISO standard for polyurethanes, and we said, well, why should we write one? We can just pull that in and make the modifications. And they said, no, we want to have our own standard on urethanes because of what we're doing in NACE. So we went through the justification, and then you do the things that you would normally have to do in a committee. You're going to have to form a committee, and many times that is difficult. I know that I've got 2 or 3 standard committees within SC03 today that has 2 or 3 members. And there's nothing wrong with that. You can have 2 or 3, but it's better to get, maybe 4 or 5, so you get a different perspective, particularly from an end user versus a manufacturer versus a general interest group. So first of all, we're challenged, and even today, I can tell you that I have 3 or 4 standards that I'm working with my NACE coordinator, Trudy Snyder, and she and I are working to try to help this chair of a particular committee find a group of people that would participate in writing this standard. You don't necessarily have to be a subject matter expert. If you have knowledge in this particular technology that you're writing, like urethane, even if you don't have any experience, if you just have a application standard, because within the standard, there's also the application part of the standard itself. So then you've now got a group of people that you said is now your committee. NACE is very proactive in terms of organizing conference calls. So as Zoom calls or team calls. We bring this group together. NACE has an existing format for their standards, so it's not like you have to develop what are the components within a standard, which I will show you in a further slide. But essentially, you start with that template and you start developing your standard. And then it becomes a repetitive process. The committee works on the standard. They get to a point where they think that they have a standard that represents the technology they're talking about. You may go through, like I said, to the peer review group. Within SC03, we're really pushing the peer review before it goes out for ballot. Then you go through the balloting process. And I can tell you there are standards that sometimes you go through 5 or 6 revisions or versions before you get to a final revision on a new standard or even on a revised standard. And you keep going through this. So you have to adjudicate each of the negatives, and you have to address the positives of the affirmative comments as well, both from the voters as well as from the observers under the new SC rules and policy. Once we've gotten a standard where everything has been resolved, we submit it back to NACE. They do their editing, and they don't edit anything. I mean, it's just a true editing process, and then it goes for publication. And then you get your 5 years, and you're at that point where you're going to start looking at a revision. And as I said, most of the new standards we're writing, we only have 2 or 3 that we're really writing within SC03, are at the point where we're moving it along. And I can give you the example of the polyurethane. Ron Rapone is the chair of that particular standard, and he and his group they're really making good progress in terms of trying to move it along. They've incorporated a group of very knowledgeable, many of them subject matter experts, and developing this standard that I think we will see sometime. I know we'll see the balloting start in first quarter of next year, with the expectation to have it completed and published by the end of next year. So that's how a new standard comes about, and what drives it is new practices or new technologies within the industry itself. The next slide talks about how you take an existing standard and revise it. And this is probably 80% of what standard committees are all about. You've got existing standards. Heat shrink sleeves is an example. 2-layer polyethylene, liquid epoxies, liquid epoxy, and you're taking this standard after 5 years. Again, you bring your committee together. You generally try to go back and look at the committee that wrote the standard or had done the last revision, try to tap those people to come back into the standard and become part of the committee. And then you go through the repetitive process again, where you look at the revisions. There's 2 types of revisions. There's editorial and there's technical changes. Editorial changes, if they're minor, don't necessarily have to be balloted after the first ballot. So as an example, if you go out with your standard, you've made the revisions and they're editorial and they're minor in change, after that first ballot, if that was the only thing, you would not have to go for a second ballot because they were considered minor. If there were major edits or if there was any technical changes, that requires another ballot. And many times a standard in a revision will go through 3 or 4 balloting processes to be able to get it to final execution. And all comments have to be resolved. And what it really requires is the committee, generally it's 1 or 2 people within the committee, go to that particular ballot voter and resolve his issue or his comments. And sometimes it could take 3 or 4 months to be able to resolve it. I mean, that's just the reality of what happens with time. And I've seen that in many of the standards, both within NACE, as well as my experience in the American Waterworks Association as well. It becomes sometimes a long process of just being able to try to resolve it. But generally we get resolved. Sometimes we don't get a resolution. And if you've got, and the rules within NACE are that if you've got 90% positive affirmative votes and you've got 1 or 2 comments that have not been resolved, you can ask for a publication, and then those particular balloters or voters who had the negative comments that were not adjudicated They can then appeal the process. You go through an appeal process within NACE, they resolve it, or they don't resolve it, and at that point, then you go for publication. I have not seen any of that really happen. All of the committees I've been involved with, and now as the SC03 chair, I have not seen a committee or a standard where we've not been able to resolve the negatives or the affirmatives. And the affirmatives are very easy. You're just concurring with it and make some minor changes. It's the negatives that really become that barrier to being able to resolve and find a good resolution. And generally, in my experience, I haven't seen that as being a problem. And then once you've got all of this resolved, it goes back to NACE. They then do their editing, doing their formatting, and then it goes out for publication. And we started the SC03 group actually in September of 2020, and we had 2 or 3 of our standards that most recently published. One particularly was the HDD. In fact, that was the first one, the horizontal directional drilling. We had the cathodic shielding paper that was written. That's a technical paper, but it was a standard. It's not really a standard, but it sort of was a legacy carryover from NACE. So we had to finish that up. That was driven by Greg Roshaw at ExxonMobil. Very excellent job by a very large committee. That committee had about 80 people on it because it was a very controversial issue. And it got resolved, and the standard has now been published. The next one is how do we, and I think I've really covered this already, all of the standards when you're working on a revision go through a balloting process, and all of them obviously has to be addressed. The negatives are the ones that you really have to spend a lot of time on. And if you've got a good committee where you've got some people that are knowledgeable in the particular technology, it becomes a little easier to be able to resolve it. We've talked about how the resolution goes through, and obviously you have to go through a rebuttal process but you've got to have that 90% vote. I did want to mention one thing that I might fail to mention earlier. Within the committee, within the group, when a standard is ready to be balloted, in the old days, prior to 2021, the balloting process would go for the full community of Nace. So you could have whatever the size of the population of Nace is, they would go out for a canvas. Would go out to every member of NACE. They would say, yes, I want to participate in that particular standard balloting process. And then you'd go through that. Under the new rules of engagement, the only members that are going to vote on a particular standard are the members within that group. So as an example, in SC03, when we have a standard going out, let's say the polyurethane as an example, when that standard goes out for balloting, it only goes to the SC03 membership. And in our case, we have 240 members. So 240 members will get this standard, whether they ask for it or not. The only ones that are required to actually vote on it or do the ballot are the voters themselves. The rest are, as I said, are observers. But generally, we look that the observers give their comments as well, because it's important as well. And so that's a little different in terms of, a lot different from what it used to be in NACE, where you have a smaller voting pool. But that pool is generally the experts on that particular group that they're working on. In the case of SC03 would be coatings and test methods. And as I said, it's a 5-year revision. After 5 years, you have to do a revision to the standard. What is a typical format for a standard? And I took the heat shrink sleeve as an example, and I've only given you the major categories within. But essentially, you would have a forward and an introduction where it talks about the technology, how it's being used, a little bit of the history of the technology. You do an overview of the technology. Definitions is one that we really get hung up on. NACE has got a good glossary of definitions, and we use those. Sometimes we want to deviate a little bit from that, and so there becomes part of the balloting process opportunities or challenges. Then you generally get into, and as I said, I'm giving you the SC03 perspective only. We would then get into the coating system properties. This would be if there were individual components, let's say in a heat shrink sleeve as an example, there's an adhesive and there's a polyethylene film. So you would have the properties of the adhesive, the properties of polyethylene film as manufactured, and then as the total product. And then you would talk about those would be qualification tables and properties. So you would have a tables on the qualification for the adhesive, qualification for the polyethylene, qualification of the total coating system. Then you would get into how the product is properly applied. The preparation is really surface preparation. Excuse me. Surface preparation. That's key in terms of being able to get a coating well bonded to the steel substrate. Then you get into the application itself, how the product is properly applied, and then you would have and then within that process, within that category, within that chapter, you would have the properties of what you would use for quality control. What are the properties that you're looking for? Is it thickness? Is it holiday detection? Is it adhesion properties? Those are generally the 3 or 4 properties that you measure. And from a quality standpoint, whether you're in the field or you're in the plant, if it's a plant applied coating system like a 2-layer or 3-layer polyethylene system. Pardon me. Then the next step would be, what are the inspection? How do you do repairs? And how do you do backfill? So it really becomes an encompassing standard, everything from definitions through the coating materials to its application, to its inspection, and then if it gets damaged, how do you repair it? And then how do you backfill? And it also backfill, what I left out was also transportation. If it's a field joint coating, then you don't have to be involved. But if it was a 2-layer, 3-layer polyethylene system like you use in India, then it would be, how do you transport that coated pipe? And then at the very end is any references that you may refer to, either as other Nace, ISO, AWWA standards, or references, technical publications that you say are pertinent to this particular standard. So those would be the components that be within a standard. And that's generally, and again, I'm giving you a perspective from the coating side. It will be different if you're talking about standards related to equipment or a process itself. As an example, in the HDD, if you look at the HDD, it will give you how you do a horizontal directional drill. It'll give you all the various aspects. Excuse me one second. Here in New England, where I live, it's very dry, so we've actually been having snow here and a little bit of rain. Not what you have in India. The next one is, what are the various standards that we have within SC03? And there are 24 different standards that are within the SC03. I've given you some of them. These are the ones, if you go on the website, if you go to the SC03, you can see all of the list of the standards that are being worked on, either as new or used. So you've got cathodic shielding and, cathodic and anodic protection. You've got coatings that are used above ground. You've got what we are, SC03, coatings for buried and immersed applications, internal coatings, surface preparations. And I'm not going to read the full thing, but it deals with all the different standards that we have within SC03, and that what you would have within the entire standards committee group itself. There's, as I said, 23 different ones. Summary. As I said, we develop these standards so they become the guidelines and basis for end users and engineering companies and consultants as they write project specifications, both in terms of materials, applications, and or the processes themselves. These standards are valid for 5 years with obviously revisions. And we have many standards that go back to the 70s. So We still continue to work on these standards, whether the technology is used or not. We feel that these standards are important. Most of the standards that we have, except for coal tar, every one of the standards is practiced, including the polyurethane, which is the new standard. And as I said, these standards, pardon me, within NACE, the standards are for materials, equipment, and process. It's easy to join a standard. All you have to do is contact NACE and ask them that you would like to join a particular SC group or a particular committee standard within that SC group. As I said, you do not have to be a NACE member. You can be a non-NACE member and become just an observer. And it's people like yourselves that really provide the long-term growth and opportunities for NACE to be able to grow through your participation. So don't be shy. I think it's a very worthwhile effort. It really helps our industry as the corrosion industry in terms of being able to write these standards. So that's essentially where I am. I will now obviously take any questions. There were no questions during the presentation. I'll entertain any and all questions that the attendees would like to ask or address.